Let us now prove some important theorems on the composition of functions. If f is a function from a to b and g is a function from b to c, such that both are 1, 1, then the composition of f and g is also 1, 1. Let's recall. When is a function said to be 1, 1? A function f defined from a to b is said to be 1, 1 if the images of distinct elements of a under f are distinct. With the help of this result, let us begin the proof. We are given that functions f and g are 1, 1. This implies that for any arbitrary elements x1 and x2 belonging to set A, if we have f of x1 is equal to f of x2, then x1 is equal to x2. Also, g of x1 is equal to g of x2 implies that x1 is equal to x2. To prove that G circle f is 1, 1, we'll show that if the composition of f and g at points x1 and x2 are equal, then x1 is equal to x2. Let us consider that the composition of f and g at points x1 and x2 are equal. By the definition of the composition of functions, g of f of x1 is equal to g of f of x2. From equation 2, this implies f of x1 is equal to f of x2. And from equation 1, this further implies that x1 is equal to x2. Hence, the composition of functions f and g from a to c is 1, 1. Let's now move on to the next theorem. If a function f from a to b and a function g from b to c are onto, then the composition of f and g is also onto. Let us consider an arbitrary element z belonging to set C. Since G is onto, there exists a pre-image y of z under function g such that g of y is equal to z. Let us denote this by equation 1. Also, we are given that f is onto, and hence, for y belonging to set B, there exists an element x belonging to set A such that f of x is equal to y. Denote this by equation 2. Therefore, G circle f of x is equal to g of f of x, which is equal to g of y from equation 2. And g of y is equal to z from equation 1. Thus, corresponding to any arbitrary element z belonging to set C, there exists an element x belonging to set A such that G circle f of x is equal to z. Hence, the composition of f and g is onto. Please note that, in general, if the composition of f and g is 1, 1, then f is 1, 1. Similarly, if the composition of f and g is onto, then g is onto. The composition of functions can be considered for n number of functions, but in this class, we are discussing only for 3 functions. If f is a function defined from x to y, g is a function defined from y to z, and h is a function defined from z to s, then the composition of functions satisfies the associative property. Consider any arbitrary element x of set X. Let's begin with the left-hand side, which is the composition of the function g circle f and h. This is equal to h of g circle f of x. This is further equal to h of g of f of x. Now, let us evaluate the right-hand side, which is the composition of the functions f and h circle g. This is equal to hog of f of x, which is further equal to h of g of f of x. Observe that the right-hand side and the left-hand side yield the same result. Hence, the composition of functions satisfies the associative law.